Okay. We are now moving on to part 2 of this problem. We read it very carefully. What are we told? We're told to use a trapezoidal sum. We're given with 3 integrals, and we're asked to approximate the definite integral from 0 to 2.8 of v sub p of t dt. Reminder, when we find the antiderivative, this is a definite integral, so what we're going to find is the area between the curve v of t and the x-axis. And so what we're finding is the change in the position. So this is really equal to x of 2.8 minus x of 0. We do notice that where is particle p at the origin? It is at 0. So really, we learned here that x of 0 is equal to 0. So when we do all of this, we find we approximate the position of the particle at time t equals 2.8. So let's start with a trapezoidal sum. That's a big clue. Let's draw an arbitrary curve. Let's draw the y-axis, the x-axis, and just draw one trapezoid. Just a reminder of how to find the area of a trapezoid. Let's say that this is x sub I minus 1. Let's say that this is x sub I. And so the two vertical lines are perpendicular to the x-axis, which means that those are the bases of the trapezoid. So this is your b sub 1, this is your b sub 2. This point is x sub I minus 1 and f of x sub I minus 1. Well, this other point has coordinates x sub I and f of x sub I. What is the area of a trapezoid? You start with the formula. The area of a trapezoid is equal to height times the first base plus the second base divided by 2. In our case, the area of the trapezoid would be equal to the height of the trapezoid, which is x sub I minus x sub I minus 1, also known as the change in x times f of x sub I minus 1 plus f of x sub I, all of this divided by 2. So that's it. If you want to rewrite it, here is just the change in x sub I, and that's the only thing that would be different. So we're going to use this formula, the formula that you see here, to approximate the area under that curve. Let's erase all of this information, not quite all of it. We will need the formula, so we will keep the formula. And so we have the integral from 0 to 2.8 of v sub p of t dt is equal to, what is it equal to? Well, we're going to use the trapezoidal approximation, so it's going to be equal to, the first interval is from 0 to 0.3, and so it's going to be equal to 0.3 minus 0. There is your change in x times the velocity of particle p evaluated at 0.3 minus plus, I apologize, plus the velocity of particle p approximated at 0 divided by 2 plus, for the second interval, the change in x will be 1.7 minus 0.3. So 1.7 minus 0.3 times v sub p of 1.7 plus, let me be consistent, v sub p of 0.3 plus v sub p of 1.7 divided by 2, and this is equal, I'm sorry, not equal to, but plus. For the last interval, we have the interval from 1.7 to 2.8, so this is 2.8 minus 1.7, and then v sub p of 2.8 plus v sub p of 1.7. What do we do? Nothing. We just follow the formula that we need to use to find the area of a trapezoid. Let's continue. This is, the first one is 0.3 times 55 plus 0. So v of 0.3 is 55, v of 0 is 0. I'm not going to point to the table every time I do something. I will not. You can go back and check. Plus 1.7 minus 0.3 is 1.4 times 55 plus negative 29 divided by 2, and then plus 2.8 minus 1.7 is 1.1 times 55 plus negative 29. Once more. All of this divided by 2. It turns out that this is approximately 40.75. Let me just check. You should take your calculator, enter that into your calculator, and I am right. It is. Well, this should be equal to 40.75. This should be approximately equal to 75. But that's that. So for this problem, there's only one thing that you need to remember, and that is, how do I find the area of a trapezoid? And that's the end.